I wanted to make this video because I was helping a student with this question and we both got stuck. Embarrassing for a math teacher especially. We got stuck and I learned something very important from this question. So let's start looking at it. What we've got is a larger right angle triangle in which we've got this line here which forms a smaller one. And what the question's asking is to find angle ACD, that is this angle here. So started working on this. What we did was okay, so we don't have enough information about this triangle yet, so let's just get some information. So we started, let's get this hypotenuse here, line BD. Fine. What we also got from it, just while we were doing that, was the size of this angle here. Now, of course, this angle, I'll call this X, plus 38 makes 180, which means that angle X must be 142. Okay, so we've taken a couple of chips out of the problem. Let's get this hypotenuse H. We've got the angle 38 degrees, we've got the opposite, we've got the hypotenuse, so we can use sine in order to find that. What we then know is that the sine of 38 is equal to 83.2 divided by that hypotenuse. Rearranging, we get 83.2 divided by sine 38 equals, just stick that into a calculator, so 83.2 divided sine 38. And we get 135.139, blah, blah, blah. So 135.139, etc. Okay. So we know this distance on this triangle. Let's just label it up. 139, blah, blah, blah. Now what we're going to do then is we're going to use that to find out some more stuff about this. Now we're focusing on this triangle DCB. So I'll just draw a little sketch of that just to help me get control of what's going on. And we know, okay, 142 degrees. And we know that this is the hypotenuse of a smaller triangle, 135.139. And we're trying to find this angle here. Now, how do we find, the other thing we know is, of course, 54.5 meters. So what we've got is two distances and we're interested in two angles. So what we might try and do then is use our sine rule. So let's give it a go. Let's say, all right, what we see is this, this angle divided by the this distance divided by the sine of this angle should give me this distance divided by the sine of this angle here. But we don't know that one yet. The thing is, if we apply the sine rule, we need this angle and this distance here. So what we're then going to need to do is apply the cosine rule because we need to find either one of these angles or one of these distances. I'll try and find this distance y. Now, remembering our cosine rule, we can look back at it, of course, because you'll have that given to you in the formula sheet. So what we can say then, all right, so y squared is equal to this squared plus this squared minus 2 times this plus this times this multiplied by the cosine of this angle. Let's write that whole thing out. So 135.139 blah, blah, blah squared plus 54.5 squared minus 135.139 times 54.5 cos of 142. Then what we'll do is we'll apply this cosine rule. We'll get the answer to this y. So I'll just type that in. So 135 point. So 135 point plus 54.5. Sorry, silence in this isn't great much fun. 54.5 cos of 142. And we take the square root, and what we get is the distance y as 181.2191722. Okay, so using that, then we can use a sine rule in order to find the angle here. But what I realized when I stepped away from this and had a bit of a think about it, because it got to a point going, hold on, we're doing so much for this question, and it is not an easy question, it's 5 marks, but there's a far easier way to do it. I'm going to erase all of this, every bit, because you can do it in basically 2 steps. We went the wrong way, or we went a correct way, but a much more difficult way. We found the length of this, but instead, what's much better is find the length of this. because then we can apply tan. So tan of 38 is equal to the opposite over adjacent, so it's 83.2 over x. So that means x is 83.2 over tan 38. 83.2 over tan 38 gives us 106.491, etc. Now that I know that, 106.491, I just add these two together, and then all I need to do, having those two sides, is I can find the angle, again using tan. So what I've got is a larger triangle, and it's this side here, 83.2, and the base is just 106.491 plus 54.5. Much, much easier. So that is, the total distance across the bottom is 160.991. Or I forgot I wrote this one over here. And then we just apply the inverse tan. So inverse tan of the opposite of the adjacent, which is 83.2 divided by 160.991. Let's do that. 83.2 divided by my previous answer, and we get 27.3 degrees. Well, that's it. So the reason I wanted to post this is because practicing exam questions is really, really going to help, especially we have to do some level of analysis, because you have to use loads and loads of different skills that you've got from the other questions in doing that. And also, if you find yourself looking at a question going, wow, this is really, really difficult, or spending a long time just looking and going, I don't know what to do here, I don't know what to do here, take a step back. Actually looking away from the problem will make it much easier to see the problem, especially if you feel you've got stuck on it, if you're just in the middle of nowhere on it. By all means, of course, if a teacher's around, ask them, and even if they will accept it, just email them.